Okay, on question number 7, we are given this expression and it's a binomial expansion that we need to do. Now, on this thing here, we would first need to rewrite this function as 1 plus 1 over 8, 1 plus 1 over 8x to the power 1 over 2. So rewrite the square root as a power half. And in the formula book, booklet, or if you're doing OCR, then on the formula sheet at the front of the question paper, you are given the binomial expansion in this form. Now, the first thing we need to check is that it does start with 1, and if it doesn't, then we'd have to take a term out. So in this case, we don't need to change this. We don't need to take any numbers out of this. So we can write this as 1 plus 1 over 8x to the power half is equal to, now the numbers that we substitute here, so our n is equal to half, n is whatever the power is, so we have n equals a half, and the x term, I'll write this sort of in inverted commas, the x term that we have is actually 1 over 8x. So when we substitute that in here, we'd be replacing each x term with 1 over 8x. So this would then become, so the sequence starts with 1, and so it's going to be 1 plus nx, so n is equal to 1 over 2 times by our x term is actually equal to 1 over 8x. The next term then is going to be plus n times n minus 1, so that's going to be a half times a minus half, divided by 2 factorial, or 2 times 1, which is just 2, times by the x squared term, so this is going to be 1 over 8x and then whole thing squared. Right? So on this question, we are only asked to expand this up to the term in x squared, so we'll just say plus dot 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 to just show that we know that the sequence just continues forever. Okay, so now we just need to simplify each of these terms. So the first two are fairly straightforward. 1 plus a half times an eighth, that would give us 1 over 16x. Now this whole thing here, I would just type into a calculator. Just be careful that when you substitute this part, you do put the 1 over 8 inside brackets and then square it. So the multiplication you need to do here is a half times a minus half, divide that by 2, times by 1 over 64, or just 1 over 8 whole thing squared. So if you did that correctly, the answer you should get for this term here is going to be minus 1 over 512 x squared. Okay, so the infinite series expansion is 1 plus 1 over 16x minus 1 over 512 x squared. Okay, so the second part of the question then is, so on part B, we are told by substituting x equals 1 in the expansion, show that square root of 2 is either equal to this thing or this thing. So the two fractions are not equal to each other. We're just asked to show one or the other. So for something like this, if you're given the value to substitute, the first thing you'd want to check is, what does this function actually equal to when x is equal to 1, right? So we'll just first substitute f of 1 to see what that gives us. So f of 1 is going to be equal to, so substituting x equals 1 into this gives us the square root of 1 plus 1 over 8. So that's going to be square root of 1 plus 1 over 8, which then simplifies to square root of 9 over 8, which I can further simplify to 3 over 2 root 2. Right? So if you put this into a calculator, you'll get a slightly different form. So if you type just this into the calculator will just rationalize the denominator for you. So in that case, what you will end up with is 3 root 2 over 4. So what we can then do, so we know that f of 1 is equal to this. This is the exact value of this function. And we know the exact value is equal to 3 root 2 over 4. What we now need to check is what is the expression we get if we substitute x equals 1 into our expansion. So it won't give us the exact value, but it should be a close approximation to 3 root 2 over 4. So substituting x equals 1 into our expansion, that gives us 1 plus 1 over 16 times 1 minus 1 over 512 times 1 squared. And all of this, if you plug everything into the calculator, what we happen to get is 543 over 512. So since we are saying the approximation, the expansion is approximately equal to the original function, we can say that these two are approximately equal to each other, right? So what I'm going to write here is then to say that 3 root 2 over 4 is equal to 543 over 512. Okay. So if you do a little bit of rearranging here, so we can multiply by 4 and then divide by 3. So I could then say square root of 2 is equal to 543 over 512 times 4 over 3. Right? And again, if you type this into your calculator, what this gives us is 181 over 128. So we can say that square root of 2 instead of the equal sign here, I'm just going to say that this is approximately equal to this. So square root of 2 is approximately equal to 181 over 128. And that's one of the forms that we are asked to show. Right? So we don't have to show both of them here. Now the reason there is a second form that we can get is a slightly different way you could have done this is to not rationalize the denominator at this stage. Right? So in that case, what we would have had is 3 over 2 root 2 is approximately equal to 543 over 512. So you'd have something like, let's say root 2 on this side, and I have 3 over 2 times 512 over 543. And if you plugged all this into the calculator, you will get the other form, which is 256 over 181. So you could also say that root 2 is approximately equal to that 256 over 181.